Let us look at proposition number 19 of book 9 of Euclid's Elements. The proposition says, given three numbers, to investigate when it is possible to find a fourth proportional to them. Okay, so here we are just given these three numbers, nothing more. So let's see how we can prove this. We are given ABC and nothing else. So we don't know whether it is in continued proportion or it is not in continued proportion. Yes. And another thing we may be interested in is whether A and C are relatively prime or not. Okay. So which means basically that there are four distinct possibilities. ABC are in continued proportion. ABC are in continued proportion. In one case, A and C are relatively prime. And in the other case, A and C are not relatively. Now, other cases are ABC are not in continued proportion, A and C are relatively prime. And the other case is ABC are not in continued proportion and A and C are not relatively. These are the four distinct possibilities. So let's take these possibilities one by one. Now, as far as the first case is concerned, you might have noticed that hardly any gap is left. That is because we don't have to do much. In one of our previous propositions, we have already shown that given a set of numbers in continued proportion, if the extremes are relatively prime, then we cannot find a fourth proportional. So, which means fourth proportional can't be found in this particular case. Now, let's look at the second case. A, B, C are not in continued proportion and A and C are relatively prime. Assuming D is the fourth proportion. Basically, what does that mean? It means that C is to D is equal to A is to B. Or in other words, A is to B is equal to C is to B. Let's take one more number. Let's take E such that B is to C is equal to D is to E. Then we have four numbers in the first proportion, four numbers in the second proportion. A, B, C, D and B, C, D, E. Here, in both these two cases, multitudes are same. That means there are four numbers here, four numbers here. Not only that, when you take 2 and 2 together, they are in the same ratio. A is to B is equal to C is to D. B is to C is equal to D is to E. Then X equally A is to C is equal to C is to E. What does this mean? It means that A measures C. It also means C measures E the same number of times. But the point is, A measures C is what we are interested in. A measures itself, a number will always measure itself. So that means A measures A and C both, and which is not possible because A and C are relatively prime. So since it is not possible, fourth proportional cannot be found. Now let's look at the third case where A, B, C are in continued proportion and A and C are not relatively. Let B be equal to B times C. Now A measures D or it does not. So this is two cases now within this case. So let's take it one by one and let's say A measures D according to E. So that means D is equal to A times E. But we already have seen that D is equal to B times C. So which means A times E is equal to B times C. If we write this in proportion form, we will end up with A is to B is equal to C is to E. So what do we have? We have, remember ABC are in continued proportion. So we have A is to B is equal to B is to C is equal to C is to E. And let me bring it E as well, just to complete the picture. So here, which is the fourth proportional? E is the fourth. That was the case when A measures D. Now the other case is when it does not measure D. So let A not measure D. assuming E to be the fourth proportional, not this particular E, just assuming a number E as a fourth proportional, we would still end up with this A times E is equal to B times C because of this assumption. And we know B times C is equal to D, A times E is equal to D. That means A measures D according to E, or more importantly, A measures D. Now you might be wondering why this suddenly after showing this equality, I'm showing this. Because we don't know whether A times E equal to D or not. We know A times E is equal to B times C. But because it is in continued proportion, we know B times C equal to D. And because of this equality, we are saying that A times E is also equal to D. And because of which we can say A measures D according to E, or in short, A measures D, which is basically a contradiction. Why? Because here we are saying A measures D, but we started off by saying A does not measure D. And because of this contradiction, fourth proportional number cannot be found. So now the last case, we can start off by saying let D be equal to B times C and follow the same arguments and see if A measures D, fourth proportional can be found. And if A does not measure D, fourth proportional cannot be found. So that is proposition number 19 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share. That's it for now.